Hey there, this is chemistry lesson 1.03 over scientific notation. Again, this is a topic that should be reviewed that you've had before, but as we use it so very often, it is a really, really important topic. So we're going to spend some time talking about this. We're going to look at how do we put numbers into and out of scientific notation. What we also want to do is go over the rules when you multiply scientific notation. And where we're going to start is, why do we even use scientific notation? There is a number that we're going to do, and it is, let's see, I'm going to write the whole thing out. You don't have to write this in your notes if you don't want to. So this number is called Avogadro's number, and it is big. And it's not uncommon to use this 12, 13, 14 times in one homework assignment. Do you really want to write this number out every time you have to use it? And the answer is, of course not. So what we do is we put it into something called scientific notation. So this number is obviously bigger than 1. If I put my pen here and I started to count over, hopefully I drew enough the correct amount of zeros. So if I counted, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 until I get my decimal here. What I would find is that I would put my number here, it would be 6.02. And if I multiply that by 10 to the 23rd power, so if you would punch that into your calculator and you asked for it to come out in long form, this would be the same as this. And so scientific notation lets us take these numbers that are really big or really small and put them into something that we can manage, we can work with, and we can put into our calculator. So for a number greater than 1, we multiply it times 10, and we have a positive exponent here. And before we go on, let's talk about the anatomy of scientific notation. So let's take this number. This front part is called the operator. The operator. And the back part then we consider to be the exponent. And we always, now you'll see in some of the homework assignments, their operators aren't always in this form. It might say 11.235 or 36.0008. For the most part, for the operators, you want these to be 3 digits. And you want to have 1 digit in front of the decimal. So for our purposes, this is going to be the easiest to do. So our scientific notation should always look like a 6.95 times 10 to the 4th, or 4.33 times 10 to the 15th. For numbers that are greater than 1, the exponent will always be positive. But what if I have a number that's less than 1? So let's say I have the number 0.0000896. Yeah. So this is a number that is a lot smaller than 1. So if I have a number less than 1, I put this into scientific notation the same way. You'll notice here, when I have a number greater than 1, I move my decimal to the left when I go into scientific notation. So when I come out, I have to go back the other way. But when I go into scientific notation for a very small number, I move my decimal to the right. So I'm going to go 1, 2, 3, 4, 5. So this is going to give me 8.96 times 10. And now I put -5. So numbers less than 1 have a negative exponent. So anytime you look at something and you see a negative exponent, you know you're looking at something lower than 1. If you see a positive exponent, you're greater than 1. How do you know when you need to use scientific notation? Basically, any number that is greater than 9, a number that's greater than 9,999 should be in scientific notation. And any number that is less than 0.001 needs to be in scientific notation. This isn't a law of science rule, this is a me rule. So on my test, if the answer is 101,250 and you don't put it into scientific notation, you'll take a half-point ding. Or if you put in 0.00062, I'll ding you for not putting it into scientific notation, because it makes it really difficult to grade these big numbers and small numbers. So it's kind of this is a me thing. And just to refresh, if you're going into scientific notation for a small number, you're going to move the decimal. You always have to go towards where your first integer is going to be. So here I have to move my decimal to the right. Here I'm going to move my decimal to the left. And when I go out of scientific notation, I'm going to reverse that. Other thing that we need to talk about is how do we multiply and divide scientific notation? In case you haven't figured it out yet, scientific notation is often abbreviated SCINO. So let's take two numbers and let's multiply them together. Let's take 2 times 10 to the 4th. We're going to multiply that by 3 times 10 to the 3rd. And when we multiply, what we're going to do is we're first going to multiply the operators, and then we're going to multiply the exponents. So here's how this looks. If I take 2 times 3, I'm going to have 6. Now I'm going to take 10 to the 4th times 10 to the 3rd. And if you remember from algebra class, when you multiply exponents, you add them. So this is going to become 10 to the 7th. So I have 6, and then when I multiply these together, 10 to the 7th. Well, couldn't you just punch it into your calculator? Yes, you could. But remembering these rules helps you look at an answer and know if you have an answer that makes sense. And I just got done taking a class this summer. This is something I have to do even in the classes that I take. So this is something you can use all the time. You'll use it all the time in chemistry. And if you come to physics, all the time in physics. Something that you'll have to be careful of. So if you do this in your calculator, and this isn't so much true for multiplication as it is for division, but I'm gonna box around this. You must use parentheses. I think it's ES. I might have spelled that wrong. You can call me on it later. I'll show you why when we do division. So if we're going to do division, we're going to kind of do the same thing. So let's take 6 times 10 to the 10th. Let's divide that by 2 times 10 to the 4th. So I'm going to go the same route again, where I'm going to multiply, or I'm going this time divide my operators. So 6 divided by 2 is 3, and 10 to the 4th divided by, or 10 to the 10th divided by 10 to the 4th. When I divide exponents, I subtract. So 10 to the 10th, 10 minus 4 is going to be 6. This is going to be 3 times 10, 6. And let's jot this down too. I'm going to go back to black. So when we multiply exponents, we add. And we divide exponents, we subtract. And this is where it really matters if you don't put that in parentheses when you enter it into your calculator. So when you enter this into your calculator, you have 6 times 10 to the 10th. Let's say you don't use parentheses, divided by 2 times 10 to the 4th. So what will happen if you put this into your calculator without using parentheses is the order of operations, it will do this first. And then it will, so that would be, let's see, 2, that would become like 2 times 10 to the negative 9th, I think. So it'll take this number, then second, it will take 6 times this negative exponent times 10 to the 4th, and it'll go 1, 2, 3. So your answer that comes up won't be the correct answer. So when you put this into your calculator, this has to be in parentheses and this has to be in parentheses to keep this grouped as scientific notation. So very important. And we'll, if you're watching this because you weren't in class, we practiced with this in class, and I want to try to get a calculator camera so we can go through this and have a video on calculator camera. All right, so what are our takeaways? Scientific notation helps us handle really big numbers or really small numbers. If the exponent is positive, it's a number that's greater than 1. If the exponent is negative, it's a number that's less than 1. We have in the scientific notation the operator and the exponent. The operator should be 3 digits, and you should always use scientific notation between 9,999 and 0.001. In addition, when we multiply these together, when we do the exponents, we add. If we divide, we subtract exponents, and make sure it is in parentheses in your calculator. All right, that takes care of scientific notation. I'll see you in the next video.